Now, let me just read a couple of the most interesting bits from this research paper. We show that a complex video game, the iconic game Doom, can be run on a neural network, an augmented version of the Open Stable Diffusion 1.4 model, which is great to know, in real time while achieving a visual quality comparable to that of the original game. While not an exact simulation, the neural model is able to perform complex game state updates such as tallying health and ammo, attacking enemies, damaging objects, opening doors, and persist the game state over long trajectories. Now, here's the thing. It doesn't actually store the state of the game in a database. So if you were to close down that model and then reopen it, it would have no way to know what the state of the game is. It doesn't actually write it to anywhere. It's all done in this neural network. And in the paper, they describe what they believe is a new paradigm for interactive video games. So today, video games are programmed by humans. Game Engine is a proof of concept for one part of a new paradigm where games are weights of a neural model, not lines of code. Game Engine shows that an architecture and model weights exist such that a neural model can effectively run a complex game interactively on existing hardware. A small part of this vision, namely creating modifications or novel behaviors for existing games, might be achievable in the shorter term. For example, we might be able to convert a set of frames into a new playable level or create a new character just based on example images without having to author code. So imagine you have a Mario game and you want a brand new world to go explore. You could basically take the existing game and simply prompt a model to give you a new world based on that game. And you could even put yourself in these video games. The possibilities are truly unlimited. Now let me talk about some of the drawbacks and potential limitations, because there definitely are some, and of course keep in mind this technology is extremely early. We're just at the beginning. So first it says the game engine suffers from a limited amount of memory. The model only has access to a little over 3 seconds of history, so it's remarkable that much of the game's logic is persisted for drastically longer time horizons. Another limitation is the fact that it is not a perfect simulation of the original game. Now, that only matters if you're trying to recreate an existing game. If you're simply generating a brand new game, that actually doesn't matter. And it's not perfect. Just like large language models, this game will hallucinate. Now, the hallucinations come out in different ways. As we can see from this video, there are little twitches in the eyebrow of the avatar. Some of the numbers that are being counted are off. We can see little awkward movements in the graphics, but overall, it does look quite good. So how do we fix all of these issues? Well, first of all, we have to get better at fixing and preventing in general hallucinations, which is a broad problem in the world of artificial intelligence. We need to be able to allow them to persist memory for longer than just a few seconds. And again, this is another problem in the world of AI. AI doesn't currently really have any memory. We use certain memory techniques like retrieval augmented generation to give large language models memory, but they don't actually have memory. They are kind of just frozen in time. And then of course, we need a lot more training data and a lot more compute. And when we mix all of these things together, I believe the future of video games is truly going to be generated, just like Jensen Huang said early last year.